Today we will discuss a new topic, thermodynamics. Okay, thermodynamics. What is thermodynamics? Thermodynamics deals with the various forms of energy and their interconversion in physical and chemical changes. Okay, I repeat, thermodynamics deals with the various forms of energy and their interconversion in physical and chemical changes. It also helps. It also helps in predicting the feasibility of a process or a reaction under given condition. Thermodynamics helps us whether a process occurs or not, whether a reaction occurs or not. So thermodynamics, what is the important of thermodynamics? Thermodynamics helps us whether a process or a chemical reaction occurs or not. This is called feasibility of a process or a reaction. What are basic terms used in thermodynamics? What are basic terms used in thermodynamics? First one, system. System. What is system? What is system? Part of universe under thermodynamic study. Part of universe. Part of universe. Part of universe under thermodynamic study. Okay. For example, take a beaker. Here water is present. So water is the system. Here you observe water. So water is the system. Okay. And another is take a vessel and C plus O2 gives rise to CO2. So this reaction is a system. Okay, system is a part of universe. So part of universe under thermodynamic study is called a system. So C plus O2 gives rise to CO2 is a system. Okay, in this process, energy is released or absorbed. This energy is exchanged between system and surroundings. Okay. Next, systems. Three types. One is open system. What is open system? First, suppose you take open vessel. It has hot water. After some time, the level of water is decreased. Why decreased? Some amount of water is escaped into the atmosphere. Okay, here matter is exchanged. Between system and the surroundings. Okay, here matter goes to surroundings. At the same time, water becomes cold. First you take hot water. After some time, water becomes cold. So here, heat and matter exchanged. Okay, this is a open system. Human body is a open system. Next, closed system. Okay, in a closed system, heat is exchanged. Heat is exchanged. It is exchanged, but not matter. But not matter. Okay, next the third one is isolated system. Isolated system. What is isolated system? Neither heat nor matter is exchanged between system and surroundings. Universe is the perfect isolated system. Universe is the perfect isolated system. Universe is the perfect isolated system. Okay. So system three types: open system, closed system, and a isolated system. Okay. And the next one, surroundings. System, part of the universe, other than system. So part of the universe other than system is called surroundings. Okay, heat is exchanged between system and surroundings. Okay, heat is exchanged between system and surroundings. Heat may be come from surroundings into system, or heat is flown into surroundings from the system. So heat is exchanged between system and surroundings. Okay. Next, rigid body, boundary. What is boundary? Separation between system and the surroundings. Separation between system and the surroundings. Separation between system and surroundings. Okay, boundary two types. One is rigid boundary. Okay, and the second one is non-rigid boundary. Okay, one is rigid boundary and the second one is non-rigid boundary. For example, this is water, this is system, and this is surroundings. Okay, this is system. This is surrounding. System and surrounding is separated by a thick wall of vessel. So, thick wall of vessel is a rigid boundary. In this case, delta V is not equal to 0. Okay, non-rigid boundary. So, delta V is equal to 0. Non-rigid boundary balloons. Non-rigid boundary. Delta V is not equal to 0. Non-rigid boundary balloon. Delta V is not equal to 0. Okay, rigid boundary and a non-rigid boundary. Rigid boundary, for example, water taken in a vessel, a thick wall of the vessel, a thick wall of vessel separates system and surroundings. Delta V is equal to 0. Balloon, in case of balloon is non-rigid boundary. Next, boundary two types. Boundary two types. One is real boundary, and the second one is imaginary boundary. Imaginary boundary. Okay. For suppose water is taken in a vessel. Water is taken in a vessel. Water is taken in a vessel. Okay. This thick wall is real boundary. Surface of water is imaginary boundary. Okay, you understand? What is real boundary? Real boundary is thick wall of vessel is real boundary. Surface of water is imaginary boundary. And the liquid surface is imaginary boundary. Okay. Next. Adiabatic and diathermic wall. Okay. What is adiabatic wall? Or adiabatic and diathermic boundary? What is adiabatic boundary? The wall which does not allow any heat transfer across it. The wall which does not allow any heat transfer across it. Example, isothermal flask. Isothermal flask. Okay. What is adiabatic boundary? The wall which does not allow any heat transfer across it. Therefore, Q is equal to 0. But what is diathermic boundary? The wall which allows heat transfer. Example, diathermic boundary. Example, copper, iron vessels. Q is not equal to 0. So what is the diathermic boundary? Which allows heat transfer. Which allows heat transfer. It is made of conducting material. It is made of conducting material. Okay, copper vessel and iron vessel are diathermic boundary. Okay, this is adiabatic boundary and diathermic boundary. Okay, next. Next, intensive property and extensive property. Intensive property. Intensive properties. What are intensive properties? What are intensive property? Property whose value remains unchanged when the system is divided into smaller parts. For example, the entire room pressure is 1 atmosphere. When this room is divided into two parts, one part pressure is 1 atmosphere and the pressure of another part is also 1 atmosphere. So, the pressure does not depend upon the size of the room. When this room is divided into small parts, if you take any small part, the pressure is constant 1 atmosphere pressure. Such properties are called intensive properties. Property whose value remains unchanged. Property whose value remains unchanged. Remains unchanged. When system is divided into divided into small parts. These are intensive properties. What are the examples for intensive properties? Pressure, volume, temperature, okay, specific heat, molar heat, density, pH, molarity, normality, molarity, refractive index, okay, molar volume, all are intensive properties. Pressure, temperature, density, specific heat capacity, molar heat capacity, refractive index, specific volume, okay, viscosity under surface tension are intensive properties. These properties independent of size of the substance or material. Such properties are called intensive properties. Next, extensive properties. Extensive properties. What are extensive properties? Property whose value changed. Property whose value is changed. When system is divided into smaller parts. Property whose value is changed. When system is when system is divided into smaller parts. Okay. Example: volume, enthalpy, volume, internal energy, enthalpy, Gibbs energy, and entropy. These are the extensive properties. Extensive property per mole per gram becomes intensive property. Extensive property per mole or per gram becomes intensive property. Okay. Volume is extensive property, but molar volume is intensive. Okay. Entropy is extensive, but molar entropy is a intensive property. Okay. Heat capacity extensive. Specific heat intense. Okay, extensive by extensive is equal to intensive. Extensive by extensive is equal to intensive. For example, density is equal to mass by volume. Density is equal to mass by volume. Mass is extensive. Volume is extensive. Extensive by extensive is equal to intensive property. Similarly, pressure is equal to force per area. Okay, force is extensive property. Area is extensive property. Extensive by extensive is equal to intensive property. Okay, you understand? Right.